Hey guys, this looks like a fun one. We're given a triangle with 3 squares inside of the triangle. We're also given that this distance is equal to 6. And the question is asking, what is the sum of these two shaded areas? This is day 9 of the 2025 Advent calendar. For the month of December, we're going to try to solve 31 Katrina Ag puzzles in 31 days. And if you want to try this one, pause it right now because I'm going to solve it in 3, 2, 1. Let's label the areas of our squares. Let's call this one x squared, this one y squared, and this one z squared. We can now write a formula for the area we're trying to solve. It'll be equal to x squared plus z squared. This looks important. Let's put a box around it and move it down here. Next, we can label this side of the square. The whole area is equal to x squared, which means the side will be equal to x. And then for this square, the area is equal to z squared, so this side will be equal to z. And then for this distance right here, the whole thing has a side length of y. This is equal to x, so this remaining portion will be equal to y minus x. And then for this portion right here, this whole thing is y. This is equal to z, so this will be equal to y minus z. And now these two triangles are similar. This angle will equal this angle because it's a right angle. This angle will equal this angle because of corresponding angles. Anytime you have a transversal cutting two parallel lines, this angle will equal this angle. Since the two triangles have 3 corresponding pairs of congruent angles, we know they are similar. That means we can write a proportion with their corresponding sides. We can say the height over the base equals the height over the base. Or in other words, x over y minus x equals y minus z over z. And then from here we can cross multiply. X times z will equal the quantity y minus x times the quantity y minus z. And then from here we can multiply all this out. Y times y would give us y squared. Negative z times y will give us negative zy, do zy. And then negative x times y will give us negative xy. And negative x times negative z will give us positive xz. Both sides of the equation contain an xz, so let's subtract xz from both sides. On the left-hand side, we'll be left with 0, and on the right-hand side, we'll have y squared minus zy minus xy. Each of these terms contains a y, so let's factor out y. Y squared divided by y is y, negative zy divided by y is negative z, and negative xy divided by y is negative x. I ran out of room, so let's clean this up and let's bring this up here. Anytime you have something times something equals 0, it'll be true if either of those somethings is equal to 0. For the first case where y equals 0, I can tell right here this square exists. Y is implied to be a positive distance, a non-zero distance. So this one is not valid. And then for this one, let's just set it all equal to y. We can add z to both sides and add x to both sides. And that'll give us y is equal to z plus x. And now let's see if we can do anything with that. I do see something we can do. Let's subtract z from both sides, and that'll give us y minus z is equal to x. And then we can start over again and let's subtract x from both sides. And that'll give us y minus x is equal to z. And I definitely have a use for these equations. Y minus x is equal to z. That means this y minus x can change into z. And then y minus z is equal to x means this y minus z can change into x. And now we should be done with this variable y. I think it'll be wise to get rid of the y's. And then from here, let's extend this side and this side, and they're going to meet at right angles. And then since this is equal to x, this will also equal x. And since this is equal to z, this will also equal z. And now we have a nice looking right triangle with a hypotenuse of 6 and a side of 2x and another side of 2z. Let's do the Pythagorean theorem. It'll be the quantity 2x squared plus the quantity 2z squared equals 6 squared. On the left-hand side, the quantity 2x squared is equal to 2 squared x squared, which is equal to 4x squared. And then the quantity 2z squared is equal to 2 squared z squared. It'll be equal to 4z squared. And then on the right-hand side, 6 squared is equal to 36. Next, let's divide both sides by 4, and we end up with x squared plus z squared is equal to 9. And that is exactly what we were trying to solve. The area is equal to x squared plus z squared. In the place of all of this, we can plug in 9, give it a label of square units, and that is the answer to our question. In this given diagram, the sum of the two shaded areas is equal to 9 square units. How exciting. And this is the question for day 10. We're given 2 semicircles inside of a larger semicircle, and that this is perpendicular to this and has a length of 2. And it wants to know what is the total shaded area. This looks like it'll be a fun one. How exciting.